The second class of compound that we're going to be looking at is molecular compounds. But before we need to do that, we need to define binary compounds. Binary compounds is a compound composed of only two elements, hence the binary. But they can be ionic, molecular, or acids. But for all the molecular compounds that we're going to be naming are in fact binary. Okay, so a molecular compound has two uncharged atoms. They're usually both nonmetals. So we are basically in the second of the three types of compounds. So basically these three types have all a set of rules. So the very first thing we need to identify is what kind of compound are we identifying so we can decide what set of rules to follow. So in doing so, the following three are all binary compounds. So we need to decide whether they are ionic or molecular. So for the first one, we have AS406. Okay, AS is right here on the periodic table, and yes, it's a metalloid on this one, but on the line that comes down through here, it's on the non-metal side. So we're going to treat it as a non-metal. So therefore, when I have the leftmost element as a non-metal, and it's only got two elements there, that's going to make this one molecular. Okay. ClF3, okay, chlorine is right here. So this, is it a metal or is it a non-metal? And the answer is non-metal. So again, two elements, but the leftmost is a non-metal, okay? So that makes this also molecular. And the last one, Fe. Fe here is here on the periodic table. So is it a metal or a non-metal? And the answer is it is a metal. So therefore, the leftmost is a metal, and there's only two elements. Therefore, it has to be ionic. Okay. So how do you name a binary molecular compound or a molecular compound? For the most part, the element on the left is just the name. Okay. You name them in the order that it's given. You add a prefix to denote how many of that element is there, how many atoms of that element are there. Except for mono, we don't use that for the left. You do use it for the right. And then the last ending, just like you do with the ionic compounds that are binary, you change the ending to IDE. So I chose this one because it's very familiar with you. Everybody pretty much is going to recognize the CO2 as being carbon dioxide. So there's one carbon atom, so I don't put mono in front of it. It's just simply carbon. Then because of the 2 here, the prefix is di, and instead of saying dioxygen, I changed the YGEN to oxide. Okay, so here applying it to something else that you may not recognize. Okay, this is sulfur, but now it's not one of them, so I have to tell how many there are. So again, the prefix for 2 is di, and then sulfur, so disulfur. The one on the right is chlorine. Okay, again, there's 2 of them, so the prefix is di, and I changed the INE to IDE. So let's practice some of those. Here, first of all, here are the prefixes. Okay, so you need to know the first 10: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay, so you need to know those 10 prefixes. Okay, so I'm going to start going ahead and doing it. First, we want to ask ourselves, is this compound N2F2, is it ionic or molecular? Okay, because that's the only two we have right now. So I look at nitrogen. Nitrogen's right here. This is represented by a nonmetal because of the fact it's going to be top of this line here. So as a nonmetal, that makes this molecular. So I have to ask myself that first. Is it molecular or is it ionic? So being molecular, I need to take the 2. The prefix for 2 is di, and then just simply nitrogen. Okay, and then the prefix again is 2, so di. And then this is fluorine, so fluorine becomes fluoride. And it's UORIDE, but again, I'm not gonna count off for spelling. Okay, most people want to reverse the O and the U to make it fluoride. Okay, The next one's CF4. Okay, here's carbon, also a nonmetal. There's one carbon, but I don't put mono for one, so simply that's just carbon. Oops. All right, and it doesn't matter if there's a prefix there, one or not, but this is 4. The prefix for 4 is tetra. Again, this is the same thing as this one, so it's tetrafluoride. Okay. This one, again, is nitrogen, a nonmetal, so this is molecular. Prefix again is 2, so this looks just like that, so it's dinitrogen. It doesn't have to be capitalized. Okay. The prefix for 5 is penta. And most of the time, even though there's an A, there's an A after penta because there's 2 vowels together, we drop the A. You can put the A in there or not put the A, I don't really care. Arsenic, we had that example on the previous slide, or on the previous problem, but we're going to count it as a nonmetal. So the prefix, or there's not one, so I have to put the prefix, so this is tetra. Arsenic, again, not 2 vowels together, so I'm just going to go ahead and start with arsenic. Okay, the prefix for 6 is hexa. And then again, oops, oh, I usually do it because I don't think about it, but you don't have it. You can put the A or not. It's actually optional. And since I already wrote it, I'm not going to erase it. So the A is optional there. You can either include it or not include it. It doesn't really matter. Okay, so that's going from the giving the name from the formula. Okay, and you can also go into reverse. Now, just as a reminder, that nomenclature is on every exam you take this semester, all 3 hour exams and the final. So it's worth your while to do as many problems from nomenclature as you can do because it was worth a lot over the entire semester. It's one of the more important things I think you will learn. And just with the ionic compounds, I expect you to be able to go backwards. Okay, so if you see this prefix of di or penta, okay, so di means 2. The atomic symbol for phosphorus is P, so P2. Oxide is oxygen, so O. And the prefix penta is 5, so P2O5. Nitrogen with no prefix means it's just simply one nitrogen. Di again is 2, and oxide is oxygen, so NO2. Dinitrogen, so N2. Tetrafluoride, so F4. And boron with no prefix, so therefore it's just a B. And tri is 3, and fluoride is F. Okay. One place I will not give credit, because if you can tell me where you see this symbol on the periodic table, I will give you credit. That symbol is not on periodic table. So do not put it down for fluorine. It is not correct. I will not even give partial credit for that because that FL does not even exist on the periodic table. So FL is not on the periodic table, it's just F for fluorine. Okay? And that is the end of this section.